Hello again. Now, this is pretty amazing. A new brain chip developed by Elon Musk and now being trialled in the UK has been described as a game changer set to transform lives. The groundbreaking Neuralink technology allows people to control electronic devices with their mind alone. And our science and technology editor, Tom Clark, has been to meet a man who's become one of the first to feel the benefits.
It's a massive change in your life where you can suddenly no longer move any of your limbs, and this kind of technology kind of gives you a new piece of hope.
Though he's paralysed from the neck down, Sebastian Gomez Pena can now control his laptop and phone using just his mind.
Everyone in my position tries to move some bit of their body to see if there is any form of recovery. But now I think I'm moving my hand to the right, to the left, thinking about clicking my fingers, and the technology just understands what I want to do, and it does it. Yep.
You wouldn't even know the chip was there until it needs a daily charge.
If you hold it to my head right there, this means this is how we charge it.
So I'm charging the chip.
That is exactly what you're doing.
A keen rugby player and musician, Seb had just finished his first term at medical school when he made one ill-judged dive off a boat on holiday.
When I dived, I hit the floor and hit my head, and alongside breaking my neck, also broke my front two teeth. And yeah, that's how I started.
But it ended up with Seb enrolling in the first UK trial of the Neuralink device, a 5-hour operation performed largely by robot, which, through a hole in his skull, inserted threads 1/10 the thickness of a human hair, connecting 1,000 electrodes to the part of his brain that controls hand movements.
It makes the experience a lot better.
This is the first time his doctors have seen him since the device was switched on.
That's brilliant.
Good control.
This technology is going to be a game changer for patients with severe neurological disability. And those patients have very little, really, to improve their independence.
Neuralink, which allowed us to access the trial but didn't want to be interviewed, now confirmed 21 people have been fitted with the device, including 7 in the UK. Some users are able to train the AI that interprets their brain signals to type on a virtual keyboard, even control a robotic arm, or just played with their children.
Oh, you smoke, man.
The company's controversial founder promises even more.
As we advance the Neuralink devices, you should be able to actually have full body control and sensors from an Optimus robot. So you could basically inhabit an Optimus robot. The future is going to be weird, but pretty cool.
Weird, and with it, serious questions about future users' safety and privacy, but a way off. Neuralink still needs to do larger trials and share its data with the public to prove these devices are safe and effective long-term. Elon Musk, whatever you think of him, does have a record of success. But in this endeavour, he depends on brave, determined volunteers like Seb to deliver it. Tom Clark, Sky News, London.
Let's speak to Dr. Anil Seth, neuroscientist and Professor of Cognitive and Computational Neuroscience at the University of Sussex. That is quite a title. Very good evening to you. Thanks for being with us. This is amazing, isn't it?
It really is. I mean, just watching that segment, I completely agree that the potential of these technologies to change the game clinically for people with paralysis, with other brain damage, brain disorders, is really remarkable.
And is the technology progressing really quickly?
It is. I mean, I think it's a bit easy to get the idea that this is something that started with Elon Musk and his company Neuralink. But actually, brain-computer interfaces of this kind stretch back a few decades. They go back till the 1990s, and there has been quite steady progress. There are other companies as well, other groups as well. A group in Stanford has done amazing things decoding speech from people with motor neuron disease who've lost the ability to speak with their mouths. But quite recently, I think the technology is improving. So one of the big challenges is an engineering challenge, where how do you get all these electrodes into the brain so that they can record from the parts of the brain that are useful for moving a limb or for moving a robot, whatever it might be, and get data of high quality. This is an engineering challenge that I think we've seen really pretty impressive progress on recently.
Yeah, it really is quite incredible. But I guess it also comes with moral questions, doesn't it? How far do we want to go with inserting chips into the brain?
That's right. I'm very glad that in the end of the segment you raised this issue. It's a kind of a slippery slope. It's very easy to go from cases which are unarguably good, restoring movement to people with paralysis, restoring speech to people with motor neuron disease, restoring sight to people who are blind, perhaps. But if you go from there to a situation where brain-computer interfaces are used, let's say there's an example where you can use it to decode inner speech, not just what people intend to say, but what people are thinking. And now we begin to transgress on some ethically very dubious terrain. I mean, many countries enshrine something like freedom of speech in their laws, but freedom of thought is another thing altogether. And once you get inside the brain, there are no other barriers left.
Wow, it does raise all sorts of questions, doesn't it? Elon Musk in that report was talking about potentially people being able to inhabit a robot as well. I mean, can you see that in the future? It's a bit dystopian, isn't it?
Well, again, I think it could be kind of useful in limited circumstances. Again, for people who can't move, who are paralyzed, then I can imagine it might be a reasonable application to think, can they move maybe not a humanoid robot around, but move a robot arm or something to do something useful, move their wheelchair around. But I do think the scenario where all of us have holes in our head and we're all inhabiting robots on somewhere else in the world, wandering around, I don't think that's something that we really need. So this is a case with brain-computer interfaces where I think we have to think ahead. It's a bit like AI in general. We've got to resist the temptation of being dazzled by the immediate use cases and the progress and think further ahead, so we ask the ethical questions about the consequences of what we're doing before it's too late.
We know 21 people have been fitted with this particular chip, 7 in the UK. Is that something that's going to increase quite rapidly?
I think that may increase pretty rapidly. So Neuralink have done some human trials. Other companies have done human trials as well. Notably, Neuralink have not really published the results of their trials. They look very impressive. No reason to doubt what's shown in the videos and so on. It seems that the medical ability to make these implants and to keep them working is improving. There are still a lot of unanswered questions. For instance, what happens after 2 or 3 years? Electrodes in the brain have a habit of moving around because, in fact, the brain itself has a bit of a habit of moving around in the skull. So there's still lots of questions about the long-term viability of this kind of technology. But certainly, I think for people with paralysis, with motor neuron disease, with other specific medical conditions, I think this could really work. Where I worry is the idea that we're going to move from a situation where there are relatively standard medical applications to a scenario where we're all invited to pop down to our high street neurosurgeon and get a new hole in the head.
Oh dear. Exciting, but proceed with caution then, I think is the message. Dr. Anil Seth, thank you so much.
Thank you.
Really fascinating. Let's end the hour with a look at the weather.